We're out here at our salinity demonstration in Sargent County, and so what I wanted to talk about today was a little bit of the biological aspect of what we see in a really saline area that we haven't improved yet with cover crops, a saline area where we've made some improvements using cover crops, and then a healthy part of the field. So we'll talk about earthworms, and then we'll also talk about soil your undies, which is a great way to find out how biologically active your soils are. We'll take a look at the saline soil first. So here in this soil, you can see that it's really tight. There's very little structure. It's quite saline because nothing is growing here. When we bury the soil undies in this part of the field, basically what we're looking to do is to see how microbes decompose 100% cotton, and undies are just a really fun way to do that. So we buried the soil undies within the top 2 inches of soil, covered them up and left them for a couple months. And in this part of the field, we actually found that there was not much decomposition of the cotton in the underwear. So it tells us that this soil is not very biologically active. They might be specially adapted to live in these saline areas, but they're just not as active as you might find in another part of the field that doesn't have salts. In this part of the field where we've had a successful catch of cover crops for 4 or 5 years now, we can actually see that the soils are improving. So not only does this part of the field have better structure, but you can also see earthworms are coming back into these soils. So some of the earthworm work that we've been doing on this field is looking at a salinity gradient and finding out if earthworms, adults and juveniles, are present or not. And at about an EC of 1 is where we start seeing the total live worm count start to decline. At an EC of 2.5, we're seeing 0 earthworms in that soil. So we always think of earthworms as a great indicator of soil health, and so that would tell us that at an EC of 2.5 or greater, that earthworms aren't present and it's just not a good environment for them to survive. What we are finding in some of the saline areas is that the adults may survive and try to and produce cocoons in those soils, but the cocoons aren't hatching successfully. So adults they're trying to colonize the saline areas, but the salts are too much for the juvenile worms to actually survive. So I also buried undies in this part of the field where the cover crop is establishing on saline ground. And you can see just the amount of decomposition of the cotton and the breakdown of the cotton, that this soil here is much more biologically active than the soil where nothing is growing and we haven't been able to reclaim that salinity. So here in the healthy part of the field where we have a history of small grains in rotation, some soybean out here, cover crops being included, we actually have a really nice soil developed. And so we'll take a look at that. You can see the earthworms again in this soil. It breaks apart fairly easy in my hands. The roots are there forming the aggregates. And this soil is just a really nice soil to farm. When I buried the undies out in this part of the field, for the same length of time that they were buried in the other parts of the field that were salt affected, you can see how much decomposition and degradation of this material occurred. So there's obviously some very active microbes in this field, using the cotton as a resource and breaking it down to basically the elastic strip on these undies. So I think we can see in these different parts of the field that are still salt affected, how we've reclaimed that part of the field using cover crops, and then also how we've really built up the healthier part of the field by using cover crops in rotation as well to maintain cover on the soil and also to keep the biological community very active.